Number 53. Uh, we have a potentiometer wire AB right here, and then we have a battery here. This wire is 40 centimeter long, and there are two resistors, 8 ohm and 12 ohm. And we take the wire of this galvanometer and move it on this HA, and at one point the galvanometer reading becomes 0. We need to find out what is the length of A and the point where the galvanometer reading becomes 0. So what happens in this circuit is this length AB creates a potential divider. So the current flows from here and it goes to the 8 ohm and 12 ohm and returns to this. In this case, creates a potential divider. The voltage between these 2 points is higher and between these 2 points is smaller because of this higher resistance value. Now when the same current flows through here, and then these 2 points, these 2 paths create a potential divider. The voltage at this point will depend upon the relative value of L and 40 minus L. So we have some value VA here, let's say call this point VA, and we have some voltage VB. The condition that there will be no current flow through this galvanometer is that the voltage at A is same as voltage at B. That means this happens when the ratio of these two resistors is same as the ratio of these two resistors. And this resistor is proportional to the length, and this resistor is proportional to the length, this length. So the condition that we give is from the Wheatstone bridge is R1 divided by R2 is equal to R3 divided by R4. R1 is 8 ohm, R2 is 12 ohm, 8 divided by 12 is L divided by 40 minus L. 4 into 2, 8, 4 into 3 is 12, L divided by 40 minus L. So 2 into 40 is 80, 2 into L is minus 2L is equal to 3L. 2L goes this side, we have 5L equal to 80, 16 into 5 is 80 divided by 5 is 16. So at 16 meter from here, the galvanometer will have 0 reading. This is good because this length has to be smaller than this length, because this resistance is higher and this resistance is smaller. So this resistance has also to be smaller, and this length has to be greater. So we have a similar problem number 54. Right here, and in this problem it's the same or similar problem. The potentiometer wire is 50 centimeter long from A to B, and when AD is equal to 30 centimeter, there is no deflection in this galvanometer, and we need to find the value of R. The value of this resistor is 6 ohm. It's a little hard to see. Sometimes I thought it's 5 ohm, but it's actually 6 ohm. So the same thing here. What we do is it creates a potential divider, and we apply the same formula. R1 divided by R2 is equal to R3 divided by R4. R1 is 6 ohm. This is something we need to find. 6 ohm divided by R equal to this length divided by this length. So R is equal to, R goes on this side, we have 6 multiplied by 2 divided by 3. 3 into 2 is 6, we have 2 into 2 is 4. So this value is going to be 4. It was expected because this is 30 ohm, this is 20 ohm. So this resistance has to be higher and this resistance has to be lower. Only then the let's say point is X and D. Only then the voltage at this point is going to be same as voltage at this point, and there will be no flow of current in the galvanometer.